Hey everyone, so in this video we're going to be looking at the big ideas for section 9.3. That's what we're going to be looking at. So um, we're really going to expand upon one sample t intervals compared to two sample t intervals. What are the changes? Because the majority of it is the same, but when we look at our four-step process, what is different? So let's start with stating our parameter and also our confidence level. So when we state our parameter, what we want to do, we're looking at the difference of two means, excuse me. So we should be looking at mu sub 1 minus mu sub 2. Now we can change the subscript if we have like males and females or juniors and seniors or something like that. But it's mu sub 1 minus mu sub 2. And we are looking at the true mean difference. That's what we're looking at for whatever the context is. Now, the other thing that we need to talk about is the confidence level and the degrees of freedom. So our confidence level is still going to be 90%, 95%, 99%. But for our confidence level, we are going to use T star for the difference between means, or a two sample T interval, the same way that we use T star for our critical value for a one sample T interval. So the confidence level is not T star, but the T star is determined by the confidence level. Now the degrees of freedom is where things get a little bit different. If we were just talking about a one sample T interval, the degrees of freedom would be n minus 1. We only have one sample, so that sample size minus 1 is the degrees of freedom. But for a two sample T interval, there are a couple of different degrees of freedom that we could use. We can either take both sample sizes added together minus 2, so n sub 1 plus n sub 2 minus 2. That's one way that we could find the degrees of freedom. Or we can be a little bit on the conservative side and take the smaller sample size, whichever one is the smaller sample size, and subtract 1, and that will give us the degrees of freedom. Both of these are acceptable. Either one of these can be used, but at some point in time during your work, you need to identify your degrees of freedom. So, and you need to show how you get that degrees of freedom. So either add the two sample sizes together, minus 2, or take the smaller sample size, minus 1. Now, you may say, well, which one should I use? Is one better than the other? Well, traditionally, if if the sample sizes are the same, so if n sub 1 is equal to n sub 2, we would use this degrees of freedom. But if n sub 1 is not equal to n sub 2, if the two sample sizes are different, we would use this degrees of freedom, the smaller one minus 1. Either one of these is okay. You're going to get different values because you're going to have a different T star, but you're still going to get full credit. You just need to identify which degrees of freedom you are using. All right, let's continue. So what about the plan? Well, the procedure, instead of calling this a one sample T interval, this is a two sample T interval for, and then we need to identify mu sub 1 minus mu sub 2, the difference between means. So we've got a new name for our procedure. The conditions are the same. We're still going to check the randomization condition. We're still going to check the 10% condition. We're still going to check the large enough or the nearly normal condition. But the difference is we have to do all of these for both, okay? Both samples need to be collected randomly. Both samples need to be less than 10% of the population size. And both samples have to be large enough, either by using the central limit theorem, or if we know that the population is normal, or we would need to graph our samples in order to determine if our sample size or if our sampling distribution will be normal. Now, in this case, if we were graphing, though, we would graph the differences. Well, actually, we can't graph the differences. I take that back. But I'll just tell you this. Most of the time for a two sample T interval, one of these two is probably going to be satisfied. You probably won't have to worry about graphing. All right, let's continue. Do the generalized formula, the specific formula, and then find your interval. Well, our generalized formula is still the point estimate plus or minus the margin of error. That's never going to change. That's always going to be our generalized formula for any confidence interval. But what about the specific formula? Well, in this case, it would be x bar sub 1 minus x bar sub 2. So in other words, the difference between the two sample means plus or minus t star, and t star is found using our degrees of freedom that we talked about earlier, times the standard error. And our standard error is this. It is the standard deviation of the first sample squared over the sample size plus the standard deviation of the second sample squared over the sample size of the second sample. So this should be familiar. This right here, we have used before, okay? We've used this before when we were adding or subtracting two variables together. And in this case, we're subtracting two variables. So we are finding the variance for the first sample over the sample size plus the variance of the second sample over the sample size. But right here is the specific formula. And then you go ahead and find the interval by plugging in all your numbers and doing your work. Finally, we get to our conclusion. Our conclusion is still going to be the same. We are blank % confident that, and then here's where it changes just a little bit. We are blank % confident that the interval from blank to blank captures, and what am I capturing? This is a key here. Okay, we are capturing the true mean difference between, that's supposed to say between, and then ... because we don't know what the context is. So I'm just giving you the overall view of it. But we are blank % confident that the interval from blank to blank captures the true mean difference that has to be there between test scores for males and females, or heights of juniors versus seniors, or whatever the context may be. Okay, so there it is. Those are the big ideas. This should all look very, very familiar. And at this point in time, you should be getting pretty good at finding intervals and running hypothesis tests. The only thing that changes is the context and the T instead of Z, and then our degrees of freedom, but the process is still the same. State, and then plan, and then do your work, and then finally write your conclusion. Hopefully this helps you understand two sample T intervals a little bit better, and hopefully you have a great day.